Okay, so let's talk about number 4. I apologize, I forgot to record this for you today, so I'm just going to make a quick video for you to kind of recap what we talked about in class. So this was the 2 trains problem. They are at opposite ends of a route that's 350 kilometers long, each heading for the other starting point. So what we did is we said, well, let's set this up as kind of a visual. So here's train 1, and it's heading this way towards train 2's stop. And then train 2 is heading the other direction towards train 1. So they're heading towards each other. The total distance between the two is 350 kilometers. All right. One train travels at 110 kilometers per hour and the other at 90 kilometers per hour. So I'm just going to kind of put that here. He travels at 110 kilometers per hour and he travels at 90 kilometers per hour. And this guy has a 20-minute head start. Okay, so we talked about whether we should use hours or minutes, and the discussion kind of centered around what our unit of measure was that was given, and our unit of measure that's given is hours. So rather than converting both 110 kilometers per hour and 90 kilometers per hour to something that uses minutes, I'm going to go ahead and convert 20 minutes into an hour, into a portion of an hour. So this is really the same thing as saying 1/3 of an hour. Okay. Now, the next thing we talked about was the idea that we're really trying to figure out when are these 2 trains going to actually meet. So we looked at the fact that if this train 2, starts 20 minutes before train 1, we're looking for that place where the 2 trains are going to actually be at the same point on the track. So maybe it's out here, and we're trying to figure out when does this happen. So what time does this happen at, where they are at the same point on the track? And we talked about how what's really happening here is that we're trying to find when their total distance traveled adds up to 350 kilometers. Because if it's not, if one train traveled, let's say train 2 traveled for 50 kilometers and train 1 only traveled for 100 kilometers, they're still going to be pretty far apart. We need to have their total distance be the same as 350 kilometers. So then we started to think about, well, let's define some variables here. Okay, I said I'm going to let x, because that's my unknown. I'm trying to figure out how long will it take or what time will it be. X is my unknown. So x is going to represent the time that the train spent traveling. Okay. And then we looked at the idea that in order to figure out how far something has traveled, so the distance something has traveled, we really need to talk about the formula to do so. And to figure out how far something travels, you need to know what speed they're traveling and how long they're traveling at that speed. And then you multiply those 2 things together. For instance, if I'm traveling 60 miles an hour for 2 hours, I know that I've traveled 120 miles because I've done 60 miles every hour for 2 hours. So the distance traveled is really found by just doing whatever our rate is, or speed, times the time we spend traveling. Okay, so I'm going to use that to help me set up an equation here. And that equation is going to look like this. Okay, I'm going to take train 2, so distance. So distance for train 2. I'm going to add to that the distance for train 1. And when I do that, what I should get is 350 kilometers. And that's going to tell me when they would meet. Okay, so now I need to just write an equation or an expression for each of those 2 distances. Now there's a couple ways you could do this, and I think the way we did it, I can't remember which way we did it in class. I'm going to go ahead and I might do it the opposite way, and if I did, that's okay. We should still end up with the same problem. The distance that train 2 travels, right? So it gets a 20-minute head start. So it's traveling for 90 kilometers per hour times X number of hours, but it gets an additional 1/3 of an hour to travel. So I'm really going to write this as X plus 1/3. That's going to represent, so the speed at which they're traveling, their rate, times the time, however many hours plus 1/3 of an hour is our time traveled. And then to that, I'm going to add the distance for train 1. Well, train 1 is traveling at 110 kilometers per hour for the same number of hours, whatever that is. And when I add those two things together, I should get 350. You could have also written this as, so the other way to write this would have been to say, okay, well, distance for train 2 would just be 90 kilometers per hour for X number of hours. And to that, we could add train 1. Now, train 1 travels for 1/3 of an hour less than train 2. So either one of these would work. At that point, you're going to distribute and solve for X, and that's going to give you the time that it takes in order for those two trains to meet.